Hello everyone, so in this video let us talk about a problem from LeetCode. It's an easy problem. The problem name is contain duplicates part 2. So the problem statement goes like this, that you're given an integer array nums and as well as an integer k. Return true if there are two distinct indexes I and j inside the array, such that nums of I is equal to nums of j, as well as the absolute difference between two indexes is less than equal to k. Now, what it actually means is that you have to find out that whether there is a duplicate of a same number, such that the differences of those occurrence of those two numbers, the indexes difference should be less than equal to k. So that the difference between those two occurrence has a difference between them, the index difference between them should be less than equal to k. How you can find out this problem? Let us take one example. So let's say this is only 1 2 3 1. So or let's extend this 1 2 3 1, and then let's say 4 5 6 1, say 1 again. Let's take an example for this. Now what you can see here is that I just want that, is there a number, okay, is there a number who has an occurrence of less than equal to, let's say, 2, okay, which means that the difference between the occurrence of that number, like if the number exists, let's say, at any given I, then the next number should be at a distance of 2, like less than equal to 2, if there exists the same number. That's the whole problem. Now how you can check it out is, let's say that I just iterate from left to right and I see one number 1, okay, then what I can do is that I just have to check that this 1 also again exists in the range of k, like k distance apart. Now for that, because I have still not iterated to this one, what I can do is that I will keep on storing in some map the occurrences of these numbers. So which means that the last occurrence of 1 which I have seen is at index, so let's say number, and index, last occurrence of number, last occurrence of number. So let's say let's take this here only. Okay, let's leave it. So what you can see is that the last occurrence of 1 occurs at index 0. Then I move to this number. The last occurrence of number 2 occurs at index 1, and 3 occurs at index 2. Now when you come to this point, you will ask that what is the last occurrence of 1 that I have seen, that like is 1 I have already seen, and if I go to the map, I can check that out easily, that 1 has occurred at index 0. Now I know that 1 is occurring here, that is at index 3, and 1 has already occurred at index 0. The difference between 3 minus 0 is equal to 3. But it means that the difference between these two numbers, like the same number occurring, is 3. But I want 2, that there should be 2 distance apart. And thus I will keep moving forward, but now I'll update the last occurrence of 1 to be 3. Why? Because see, let's say that 1 again occurs here, or let's say here again, or anywhere, let's say 1 here again. Now because I want that the difference between this one and the last one which I have seen should be less than equal to k, why should I keep bothering about this one? Even if I have seen a one that is very far behind and I've seen a new one at this point, I should only compare this one and this one. Now why to compare the distance between this one and this one? I hope you get the point. So which means that I have to only store the value of the closest one. Okay, that is why I only store the value of the last occurrence. Like whenever I see a number and if I see it again, I will update the values, because now if I again see that value, I should not be comparing this with the very first occurrence of 1, but the very closest occurrence of 1, so because then the difference can be less than equal to k. I hope you get the point. And thus that is how I'll update the value of 1, that is now equal to 3. I'll go to this point. Now 4 has not occurred anywhere inside the map, so this is the first occurrence. So I'll just update that I've seen 4 at index 4, and 5 at index 5. Keep on moving like this. Now 6 at index, let's say 6. Now 1 again I've seen at this index, that is index 3, and now again at index 7. The difference between them is 7 minus 3, that is 4, which is already very large. So which means that now I will update this value of 1 to let's say 7, which means that now I've seen it index 7. Now when I again see it index 8, I see that again what is the last sequence of 1 that I've seen? I've seen at 7. So 7 minus 8, like 8 minus 7 is equal to 1. Which means that now the absolute difference is 1, which is less than equal to k. So now this is valid. So now I've found out one pair and we can just print out the answer. Even if we want to find out the pair value or what the last sequence, we can also like use the map here. But that's the overall logic here, that how you can check it out. And that's the overall, let's move on to the code part. So we can use an unordered map. You can use a map also. You can use an array also to act like a map to the last occurrence, whatever you want, according to the time complexities you want. And then this is n iterated over the whole length. Then m dot count. This means that I have already, like whatever ith index I am on, have I already seen it. If I have not seen it, then update the value of the current nums of I inside the map, and the map value is the current index which I have seen this. If I've already seen this, then what I'll do is I will update, like I will just check that whether the current index and the last occurrence which I've seen, the difference between them, the absolute difference, is less than equal to k, which means that I have found a particular pair. I'll just return true that I have found the pair. Else if I not find out the pair, then I'll return false that I have not found a pair. And at every point of time, whenever you see a new number that have occurred, update the index. That is completely like update the index so that the no very far values like stored in the map. I have the very latest values. That's the overall logic for this problem. The time complexity here is that I'm doing a for loop, and then for loop I'm doing a map check, that is I'm using an like unordered map, which is like an average of O of 1 time complexity. But if you just use only map also, then O of n log n. If you use a map, ordered map, it is O of n, because I'm just assuming that ordered map takes O of 1 average time complexity, and so on. So that is the overall logic and code part for this problem. Thank you for watching this video till the end. I will see you next one. Keep coding and bye.